Hello again. This is a continuation of this MakerWorld project to make the Bambulab hot end adapter, and it went well. Here's the whole project. You can review it, its files, the materials you need, and the filaments I recommend. Not PLA, not PETG either, although I didn't have any problems with them, but they worked perfectly. But of course, all of this was for making it out of plastic. And the best solution was to have them made using CNC and 3D printing in aluminum and steel, completely in metal. And here's where JLCCNC comes in, the sponsor of this video. Here's the unboxing of their two adapters, the CNC aluminum one and the steel one. This is the steel one. The quality is truly incredible, and it's completely 3D printed. In this case, the steel one doesn't have threads. You have to add them manually. Both have some modifications compared to the original design to reduce weight, but the steel version is very, very heavy. This is the CNC one, which is incredible. The quality is spectacular, including its threads and tolerances. Here you can see them side by side, and they're beautiful. Kick off to JLCCNC. Here's how to order them on their website. Go to JLCCNC and upload the model with threads, which you can find in your MakerWorld project. Let it upload to their platform, select aluminum, and choose the finish and any tolerances you want, such as production rules. The important part is the threading. You need to confirm that. Select it and upload the PDF I've included in the project where the threads are automatically marked. With that, they'll take care of machining them. In the product description, you need to select a description for your order. I recommend a bracket, which is simply a support. You can choose the manufacturing time depending on how quickly you need it. They also have a first order offer. Your first purchase comes with up to $123 in coupons. Amazing, I highly recommend them. Here we'll start with the ceramic and Thermistor from the Elegoo Hotends. I recommend using the official ones, either buying them separately or extracting both from an Elegoo Hotend. This is mainly because the beta coefficient required for the ceramic is different. Bambulab uses 3,950 and Elegoo uses 4,300, and this value is important, or you'll lose 20 degrees Celsius in your measurements. I've included some specifications in the video description, as well as thanks to Sauna from Reddit for their research on this topic, their adapter project, and the support they've given me. Just like when you add the thermal paste, it has to be boron nitride thermal paste because the temperatures are very high and regular computer thermal paste won't work. Ryan from Facebook explained this to me. He's an amazing person who has helped and given this adapter to many people. Now let's test how well the heater assembly fits. As you can see, the CNC threads are spectacular, as is their quality. It fits without problems, the tolerances are correct, and the screws tighten properly. We put the A1 hotend on just to test, and it fits perfectly. We're also going to try one from the H2D high flow hotend. Perfect, secure, and stable. In the case of the 3D printing in metal, I had a problem with the tolerances, which is part of the manufacturing process that I hadn't taken into account. I simply had to file down the sides a little, but this will be corrected in the project so you don't have this problem. After that, it fits perfectly. Let's talk about weights. The Elegoo Hotend weighs about 39 grams. The plastic adapter alone about 13 grams, and the plastic adapter with the whole assembly about 38 to 39 grams. The CNC version weighs about 44.5 grams, about 7 grams more than the original weights. But the steel version weighs 81, almost 82 grams. That's a lot for the print head. The first thing we have to do is print the shroud fan that you have from this project. Here I'll show you a bit of my resin control app, which I mainly created for Elegoo resin printers like the Saturns and the Mars with Wi-Fi, but I made it compatible with the Centauri Carbon, available for iPhone, iPad, and macOS. Once the shroud fan is printed, we simply need to assemble it. You can use any type of plastic, but it's recommended to use one that can withstand high temperatures. First, we'll remove the official Elegoo Hotend as well as the fan. I recommend using a really strong screwdriver because of the hardness of the plastic and taking your time. Now we're going to fully assemble the heater assembly on the CNC aluminum version. First, we connect the fan adapter. You can modify it as you wish. It's in the project. Now we attach the aluminum adapter. We connect the cables, tidy them up a bit, and position them. We put in the screws, and that's it. Now we attach the Hotend. In this case, it will be the one from the 0.4 millimeters H2D. The silicone sock is crucial, otherwise you'll have problems. Then we connect the external fan, and that's it. Now, the first thing we do is set the temperature to 220 degrees and extrude a little filament. This is done manually. Once that's done, run the PID tuning test at either 220 or 240 degrees. Let the process complete. When it's finished, you just need to perform automatic leveling on the side of the print bed you're using. Now we can print our first benchy to test it. I'm speeding up this process a bit because we've all seen a benchy. And it prints perfectly. As you can see, it's still the aluminum CNC adapter. Now we're moving on to the steel adapter. We're going to thread the adapter. The threading process is usually steps 1, 2, and 3, and you should use lubricant carefully. I'm going to cut this because it's quite a long and tedious process. It's not a problem to do it manually, but I recommend you order them pre-threaded. As you can see, there are marks left from the process on the back, which is what you need to file down. I've also filed down the area above the Hotend screws so it looks neat. I've also widened the filament inlet hole with a 2mm drill bit. We installed the heater assembly. Here are both versions together. We carefully connected the cables. And installed the screws. I only did a few prints with it. It's very heavy, and I don't think it's good for the print head. We attached the Hotend and the silicone sock. Here you can see everything installed. We followed the same process. First, the temperature was set to 220 degrees, then we extruded a little filament, and the other two processes were the same. First, the PID tuning and then the auto leveling. In this case, I went straight to printing the benching. As you can see, it doesn't align well and ends up outside the print bed. I discovered this in one of the first prints, but I also wanted to show it in the video. This is because in the metal 3D printing manufacturing process, the tolerances are much larger and not the same as the digital size. But even so, the print came out perfectly. The benching looks great, and since it's steel, there are no heat dissipation problems. For those of you who choose the plastic version, I tried two things. Since this area was burning due to using basic filament materials, like PETG or PLA+, which isn't recommended, it's better to use PPS or PAHT, I tried a high temperature sealant adhesive. The other test was with an adhesive aluminum sheet for vehicles, which also works. It's more durable and the plastic doesn't melt in the same way. Thank you all for your support of this project. As I said, you're free to modify it, make your own versions, and if you sell it, it's necessary that a portion of the profits be donated to charity, whatever cause you prefer. I'm not looking for financial gain from this. Above all, a big thank you to the sponsor, JLCCNC, especially Vicky for her immense patience. I'm sharing a discount code she gave me for you all. I'm not getting anything out of it. I also want to thank Ryan, Sauna, and everyone else who has supported the project again. I've already seen new versions of your work on Reddit and other platforms. I've included information about them in the description. It's taken me so long to publish all this because of the false accusations of intellectual property infringement, which many of you are aware of. But hey, there's no problem that can't be solved. This is a project for the 3D community. I also want to apologize to our samples because I didn't know the shroud fan design was made from him. A colleague shared it with me on Reddit, and I used it as part of the project. It was entirely my mistake, and I apologize to him here. I include the credit and some information about him and his projects in the description. Thanks to everyone.